Okay, another problem. We have find the measure of each angle. So I'm just going to zoom in on the diagram and we're going to find the measure of each of these angles. And there's a whole lot of different ways in which you can proceed. You can look at parallel lines being intersected by a transversal. You can look at triangles that where the interior angles had to equal 180. You can find angles that are supplementary, or 3 or 4 angles that add to equal 180 because they form a straight line. There's a lot of different ways of finding each individual angle, and all of the different routes you can take to find all of the angles, very numerous. So in any case, we'll get started, and I'm going to start right here. If this angle is equal to 50, if you look at this Z-shaped figure, alternate interior angles, the inside corners of the Z have to be congruent because the top line is parallel to the bottom line. So therefore, the angle at the top is 50. Alternate interior angles are congruent. Now you can proceed quite a few different ways. We can find a different Z-shaped figure, say this one that I'm highlighting in green, and that Z-shaped figure, the inside corners have to be congruent, so the inside corners would be this angle 70 and this angle another 70. So alternate interior angles are still congruent. And now to proceed yet again, we can find a lot of different angles. What I'm going to do is back up on some of this, and I'll erase too much. And looking at this angle, let's get a different color. This angle, those two angles are adjacent to each other, so therefore they total 120. 70 plus 50 is equal to 120. That angle, and if you look at this line, these two lines, and this third line, that's a pair of parallel lines being intersected by a transversal corresponding angles. These two angles with the purple arcs being drawn across them, they have to be congruent, so therefore this angle is equal to 120 as well. And getting rid of some of that diagram, scribble that is. Now that we have that angle, we can state that the angle right below the 120, this angle, has to be its supplement because those two angles form a straight line. So that makes this angle equal to 60. Now if you look at this triangle, the angles for that triangle add to equal 180. The first two angles, 60 and 70, they add to equal 130. Subtract from 180, you get 50 degrees for this angle. So that's one way you could find that angle. And another way you could have found that angle is to state that this Z-shaped figure, formed by parallel lines and a transversal, alternate interior angles are congruent, so therefore those two angles would have to be congruent. So that's another way of justifying that 50 degrees is correct. And now we can proceed again a bunch of different ways. We can say that vertical angles are congruent, so this angle and this angle are vertical angles, so therefore there's a pair of 50s. We can state that this triangle has to add to equal 180, so the first two angles total 120, and therefore subtracting you get 60. And if you notice these two angles, the 60s, they're alternate interior angles formed by another pair of parallel lines and a transversal, so therefore they had to be congruent, 60 and 60 that is. And continuing, we have a whole lot of different ways of continuing on the problem. Let's look at this 34 degree angle. That angle and this angle over here are alternate interior angles formed by two lines and a transversal. So therefore they have to be equal to each other. So if this angle in the bottom right is 34, this angle in the top left part of the diagram is also 34. Alternate interior angles are congruent. And now we have, once again, a bunch of different ways of continuing. This triangle that I'm highlighting, those angles have to add to equal 180, so therefore 34 and 120, that totals 154. Subtracted from 180 gives you 26 for this angle, the missing angle in that triangle. Now vertical angles have to be congruent, so therefore if that angle is 26, this angle over here is 26. And we're getting close to being finished. The angles for, let's see, get rid of some of these things. These three angles have to total 180. If the first two angles, 26 and 50, total 76, subtracting that from 180 gives you 104. That's this angle. Now vertical angles are congruent, so therefore there's another 104 down here. And now we can proceed a few different ways. We can look at one of the two triangles, this triangle or the triangle at the top. We know two out of the three angles for this triangle, 50 and 104, they total 154. Subtracted from 180 gives you 26. So therefore this angle is 26. And the same thing up here, we could have looked at this triangle, found that angle is equal to 26 for the same reason, or we could have looked at the diagram yet another way, and you might notice a Z-shaped figure. This is formed by parallel lines and a transversal, so alternate interior angles have to be congruent. So that's yet another way of answering that part of the question, and in any case we found all of the angles. Good luck.